Hello, y'all. Tim Nutt here, and this is the homework assignment for the most excellent Raspberry Pi Pico W tutorial series by Paul McWhorter. And this is for the homework assignment for lesson 3. These homework assignment videos are geared for the absolute beginner and show how to complete the homework assignment using only what has been given or portrayed, taught thus far in the lessons. And that way, if you're an absolute beginner, never program, never touch anything in your electronic, you're brand new to the Pico W, you don't need any extra training or knowledge other than what's already been given in the lessons. Paul does a very good job of starting from ground zero and making sure that anyone that wants to learn can follow along and learn. And that's kind of what I want to do with these homework assignments. So with that being said, the homework assignment for this lesson is to create a 4-bit binary counter using 4 LEDs, 4 of the GPIO pins, and 4 current limiting resistors. And then we'll code it up. Let me switch over to this view, and let's start building our circuit there. Now you noticed on the other other videos I've had the Pico W in the center, where we had pins on each side. For this particular build, I offset it because that gave me 4 available rows, and that way I can make it kind of my own version of neat with the wires there. So first I'm gonna hook up the ground on or bounce from one side to the other because I'm actually going to use both ground rails for this one just to make it neater. Jumper to wire there from one ground rail to the other, and then the next one we're gonna go, and I'm gonna use physical pin 3 as a ground. I'm gonna jump that. So pin 1, 2, 3. It's in this row, this column. I'm just going to jumper that over there. 1, 2, 3, and it's the ground. So that way we'll get our ground from there, and the jumper wire over here will take ground from one side to the other. And for this one, I'm going to be using GPIO pin 15, 14, 13, and I believe 6, just because that's how the little jumper wires I have, those were the best ones that allowed me to make it neat and organized and tidy there. Especially when we get into more complex builds, that'll be an even more of a concern to make sure it's nice and neat. It's good practice anyway, but if you keep it nice and neat, it's a lot easier to troubleshoot and figure out if something went wrong, where it went wrong at. Let me double check that. Let's bring this a little closer to the, let's see here. I don't focus very good up there. We'll just leave it down here. All right, so GPIO pin 15 is on physical pin 20. And then GPIO pin 14 is physical pin 19. Physical pin 18 is the ground, so GPIO pin 13 is physical pin 17. And then, so 1, 2, 3, 4, 5, 6, 7, 8, 9. GPIO pin 6 is on physical pin 9. So I'm going to use 6, 13, 14, and 15. Now I'm going to do things a little bit different. Up until now in the tutorials, or Paul has always shown the current limiting resistor on the positive leg of the LED. And that works great. It can actually be on either side because it's still limiting the current for that circuit. So you can have it on the negative or the positive side. Just to make things easier this time, I'm going to put it on the positive side, or I'm going to put the current limiting resistor on the negative side, just so I can line the LEDs up nice and neat. So our positive or long leg will be connected to the wires that I just laid out, which goes to the GPIO pins. That's where we'll be getting our positive voltage from. And make sure the long leg goes to the positive, the short leg goes to ground. And here's the fourth one, short to negative, positive to ground. Now they're all nice, neat, in order. Now we need our current limiting resistors in. So let me make sure we jumper to ground. That's why I put the jumper wire on the bottom side of the board, so to make it easier to put these resistors in. And I would utilize there, just make it nice and neat. Now we just need to make sure that we have them in the correct rows and columns. All right, jumper this one across on that one, and make sure we line this one up for the fourth one. All right, I believe that did that. Try to tidy it up a little bit, make it a little more closer to neat. Now I believe we have our circuit hooked up. So now we need to hop over in the code, and I'm just going to turn them all on first to make sure I hooked it up correctly. And that way, if there's any problems, we can figure it out now instead of trying to figure it out if it's code or the circuit. So first we need to import our pins from machine, import pin with a capital pin library, capital pin, capital P, and we need to add a sleep in there. So from time, import sleep. That's where we'll get our delay from, because we're going to put a 1 second delay in between each number that it counts. So now let's do, and so I set this up. We're going to use pin 15, no, actually pin 6 for the 1 place, pin 13 for the 2 place, GPIO pin 14 for the 4 place, and GPIO pin 15 for the 8 place. So now we need to set our pins up. So in order to do that, we're going to say 1 place equals pin parentheses, and we said the 1 place was pin 6, comma, pin dot out, shows it's an output pin, and then 2 place, if I could type, 2 place equals pin, and that is going to be pin 13, pin.out, and the 4 place is going to equal pin 14, comma, pin.out, and 8th place equals pin 15, comma, pin.out. All right, and I'm going to go ahead and, since we'll use it later, we're already up in this. Oh, I guess it would help if I closed my parameter there. Now we can hit enter. And I'm going to add a space, and we're just going to set up our sleep. So we'll just do, let's just do delay is equal to 1. We'll do that for 1 second. All right. Now that we have that, let's do 1 place, because we're going to turn them on now, just to make sure everything works. 1 place dot value is going to be 1. 2 place dot value is going to be 2. Or not 2. That's the second place. That's not going to work very well. Actually, it might work, but it's not correct. We'll just leave it at that. 4 place value is going to be 1 to turn it on. 1 is on and 0 is off. And then 8 place value is also 1. So now, if we did everything correct, we should be able to turn all 4 LEDs on. Let's hold our breath, and boom, all 4 of them went on. And if we change these to 0, which we'll go ahead and do now, because that'll be our first number, all of them zeros, off will be for the binary representation of 0. And let's hit run again, and they went off. Good deal. So now what I want to do is I want to make it a little easier and comment. We'll comment each one. That way we'll change it each time. Let's put a space there, make it a little easier. And that way it'll it'll help us which one we want. And actually, we almost forgot something, because we want this to repeat over and over. So we're going to create a while true, colon. And now that's where we actually want that. So that way it'll repeat over and over. So we're going to copy this, Control C. And there we just backspace it. And that's so we're tabbed in, Control V. That didn't work. Let's actually tab each of these in so that now we'll copy this, Control C, and now we should I guess it'd be better if we had a space in there. Anyway, no, I almost forgot. We need our little cheat sheet up. There we go. Now it's up. So now we have a representation. We need the zeros. That tells us what position each one's going to be to represent that number. So let's go and change this to a 1, since it's going to be the 1. Since it's the 1's place, we'll turn the 1 on. And we'll Control V again. Change that to 2. Now the 2 place will be on. And Control V, change that to 3. And then the 2 and the 1 place will be on, representing 3. Control V again. And this is number 4. So we'll turn the 4 place on. Control V. Now we need number 5. So we'll have the 4 place on. The 1. And then we need to add one more. So we'll turn the 1 place on. So 1 plus 4 is 5. And make that 6. So now to make 6, that'd be 2 plus 4. So the 1 place, or 1 on for the 4 place, and turn that on for 2 place. And then we'll go as number 7 is next. So it'll be a 4 turned on, the 2 turned on, which makes 6, and the 1 turned on, which makes 7. And we change this to our number 8. Now we can turn our 8 place on as a 1. And now since we can see in our list the 8 place will be turned on for the rest of the time, so to make it a little easier on us, we will go ahead and copy this with Control C. That way we won't have to change that one for the rest of the numbers there. Control V again, make it a 9. So the 8 is on. We need to turn the 1 also on to make it 9. Now for 10, 8 places on. 8 plus 2 equals 10. So we'll turn that one on. And now number 11. So 8 and 2 is 10. Plus 1 more equals 11. And then we'll do this number 12. So 8 and 4 equals 12. Oh, I'm typing what I'm talking. That could get us in trouble. All right, now it's number 13. So 8 plus 4 is 12. Plus 1 more is 13. Control V. 14. 8 and 4 is 12. Plus 2 more is 14. And this should be our last one, number 15. And that way, and 8 plus 4 is 12. Plus 2 more is 14. Plus 1 more is 15. Now let's go double check everything and make sure we got it. We got we know it turns them on and off, but we have our pin library imported. We have our time library for our sleep imported. And we didn't actually put our delay in there. So now we're going to have to add that all itself. We'll copy and paste to make it a little easier. But otherwise, it'll switch back and forth so fast that they'll all just look like they're lit up. And actually, I'm going to show you what that looks like before we get going. And then we'll go back and fix it. Yep, see, it just shows them all lit up all the time because it's switching back and forth through them so fast we can't differentiate it. All right, so let's stop it. And now we'll put our delay in. So we'll do sleep and make that DELAY what delay is what we set, because we set our variable, so we don't want to keep putting ones, and that way if we change everything, we'd have to go down through every single line and change it. So we just want to put declare it up here. Now if we're going to change it, we just change it once. So let's Control C on that and Control V. And then we'll just do that down the rest of the way so that we'll have our delay. And yes, these videos are all recorded live. I'm not editing it out, so that way you can see mistakes and realize them. And technically, according to Paul McWhorter, that was not an error because we caught it before we ran the code. I just decided to run the code to show you what it was going to do. And that way, maybe if you run into that issue, you'll see that, why are all my lights on? I've changed them all, but there's no delay there. And that makes them all just turn on with this particular code that we wrote. Because it changes so fast, we can't see it. So now, there's a couple more. We have all our delays in. All right, now let's try to run our code and see if we can get them to count up through. So everybody hold your breath. And here we go. 0, there's our 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. Back to 0, and it counts over again. So we did it. See how much difference the delay makes there? You wrote out all the code, and it just turned them all on. And they were just switching so fast that we couldn't see it. Now we added the 1 second delay in there, as we in the Pico W, the sleep, it goes off at 1 equals 1 second. Or like Arduino, it runs off of milliseconds, so you'd have to put 1,000 milliseconds to make a second. But with this library, 1 is equal to 1 second, and then you could change that from there. If you wanted a half a second, you just put 0.5 in there, and we'll run it. You can see how fast it switches through with doing it that way. Switches through a lot faster because there's a different delay in there. Or if you wanted to change it to 2 seconds, say. Let's go ahead and we'll run that. Now it'll stay lit up for 2 seconds before it switches. And that's why we declare our variables up top, and we don't use any constants down in the code. That way, if we need to change something, we could just change it once instead of changing it 16 times. But anyway, that's all for this one, and I hope it was maybe helpful for someone, and if so, please feel free to leave a comment, a like, or share it. Maybe there's another beginner that might catch some help from it, and hope everyone has a awesome day or evening or night or morning or whatever time it is that you're watching this. And we will see you on the next homework assignment. Goodbye for now, y'all.